Let me take a minute to revise so that we connect the dots from previous classes. Okay, we started from okay here. So this is what we are trying to play around with, and then uh, cross compilation is one of the things that you need to keep in mind, and virtual machine or the interpreter. And in session two, we this studied about what are the data types and why do they exist. So most of the classes, I'll take some time to like 15 to 20 minutes to connect from what you already know, or there is a gap between what you already know and what we are learning. So I'm trying to connect that dot from, say if you are coming from C or C++ background, of taking from that and uh, talking about Python. So that is why I give you a little bit of history, because once we start coding, so if there is no uh, the reasoning why we are using this, then things won't connect, and it will be demotivating to write a program. So why am I even doing that? So that's the mode I'm trying to teach. Okay, so these are the data types, and remember train station. So you will have all the data types in your mind, like strings, list, tuple, set, dictionary. Some of them are mutable, some of them are immutable. Immutable means read only. And then you can also mix data types. So you can put dictionary inside list, list inside dictionary, and so on. So today we'll look more into this mixed types and nested data types and why it is used. And there are list of keywords. As you program, you will get to know. So, and then if else condition, and about loops. So just remember that when you trying to loop through a data type which is an iterable means we should uh, one second, let me move it. Okay. So iterable means you need to be able to go from one memory to another memory using the previous location. So that is a iterable. So like list, a dictionary, and tuple, all of these are iterables. And yesterday we also saw how do you create your own data types. And we learned about functions. Functions, there are three main things to remember. One is the definition of the function, there is def keyword, and then it returns something. And also we can pass a lot of arguments. Some of the arguments can be default arguments. So those are things to remember. And also learned about scoping. It's slightly different from C++ to Python. Just remember that. So as you program, you'll come to a place that some variables are not accessible, or the variable that you want to edit or overwrite doesn't get overwritten. So just keep this in mind. So there is something called a scope. And yeah, we learned about little bit about objects. In Python, everything is an object. So just remember that even functions are object. So all the data types are, of course, objects. So even the files are object. Files are nothing but modules. We'll look at it later. But everything is an object in Python. So once it gets into the memory, it's an object. So we looked at objects. In objects, you need to remember two things. Object means there are two things getting involved. One is attributes, another is operation. So all the real world, we're trying to simulate the real world um, objects into the computer world. So that is how the object-oriented programming came into picture. And user input, we'll see. That's it's not a big concept. I'll cover it later. We learned about files. So files are expensive to read. So there is a way to read a file, write a file, append a file. So yesterday showed you an example like how do students take down notes from class. Just remember that. So there you need to think step by step, and only then you can operate on files, or else you'll end up overwriting it or deleting all the contents. So that is about files. So carrying on from the files, we will go to something which is called as data interchange formats. And I'll try to explain why data change in data interchange formats were formed. So that is important. And how do we parse it? But actually, programming is the easiest part in computer science. So mostly is about why it is there. So once you know why it is there, then you can easily do that. Let me take on. Let me unmute it. Go back here. Delete. So little bit about how the computer programs communicate with each other. So that is the basis of all these data interchange formats. So when you have a computer uh, within within the computer, how processes communicate. Okay, so how does operating system come to know that when you click on close this particular PPT or close say WhatsApp on your mobile, or when you download app from your app store, so how does other programs come to know that something is coming up, I need to configure? And how does privacy settings come to know that there is an app? Okay, so these are all examples for interprocess communication inside the computer. So how does the computer work? We have seen, so we have a RAM, again going back there, and then we have hard disk and CPU. So there is, imagine there is process P1 and another process P2, some process. They need to communicate with each other. So we have seen, generally when we think about passing the message to another process, so usually what we do is, if you do not know about any of these things, so you know the file operations. So what you might be end up doing is writing some data into the file. Say, for example, one process has done finishing some job, and then other process need to get to know that. So you'll write something like done in the file and then close it, and you'll have a loop wherein you wait for this file, and then you pick up. If it is done, you'll start processing it. So what is happening in this raw method of processing is that one is file operation. Another is this file is not guaranteed to be there always. For example, somebody can move it out, and some sort of cleanup processes can delete them, or you other process can overwrite it or anything like that. So that is one thing, and the second thing is like it's too expensive to write to a file, and you cannot have a certain format of communication. So we'll see that. So internally, how does process communicate? There is something called as IPC, interprocess communication, defined by operating systems. So you might have heard about shared memory and queues and so on. So what they do is, uh, the underlying concept is do some sort of um memory reservation on RAM and use it as a common space so that these processes can go and read and pick it up. So we the systems where we do not have hard disks at all, of course we cannot write any files, and also it is dangerous to communicate through the disk. It takes almost 4 times as to reprocess, and also it is expensive and risky. So you reserve a memory, and then you write something, and other process can read from there and things like that. So this is called as inter-process communication, which is IPC. Okay. So next thing is, so now we had single computers in, it was not connected to network, and if you had to communicate from one computer to another computer, want to transfer data from one computer to another computer, Those days we used to have floppy disks, which are like 5.5 inch floppy disks. We need to like just like hard disk, you write something and then you put it there, put it onto the other one, and start writing it. So that is it's like Stone Age, right? So now we have computers which are connected on the internet. So we have computers all over the internet, and they are connected here. So one of the interprocess communication from one computer to another computer is through uh, something called as ports. So how these ports came into picture is that, so people started manufacturing something called as network interface cards. So this you might have heard in your office, like when you purchase a computer, there is a NIC card that you get, and you can write bytes into this, some bytes or um, some data, and it can go through onboarded to the network, and from the network it can go to another computer. In fact, you can use the same NIC port to communicate within the computer itself. Like you can open the port and you can write something, other process can read from that port. So this is also called as sockets. So this is a little bit of introduction on to how these things were um, formed. This is the history. And then uh, now we know that we have ports to communicate in between computers. And now the challenge is, okay, there should be some sort of communication which is meaningful. So because there was internet, which is like now coming to picture. So initially, it was just between college networks. There was only few primitive functions that you could do on internet. For example, you might have heard about FTP, which is file transfer protocol, and later on we define something called as HTTP, on which currently all the internet works. So from even before there was something else. So FTP is like primitive because to our idea is to transfer files from one place to another. So files are nothing but some data from one place to another place. But how do you communicate in such a way that it is structured? So once people started defining HTTP, this is a protocol, and they wanted to communicate, they wanted to access resources from other computers. So what do you mean by resources is, so if I want to give some, say, assignments to my friend in 1990s, I would take a floppy and then write it and give it to him. Or in the early 2000s, there were pen drives. So we used to have those pen drives and late 90s as well. So and exchange the data. So now I think we almost don't use any of these devices. We just upload the file, send it on WhatsApp and things like that. So now we take it for granted. So those days, internet was used to be very costly, and uh, file transfers are, forget about it. Like it's like if you want to upload a file, you would have to wait for, say, a movie. You would have to wait for like half a day or something like that. So probably even a whole night you start uploading it and leave it like that. So it used to be like that. So now we have defined HTTP here. So, and then we are trying to transfer the files, which is one of the operations is upload and download. So within that, there are several functions. So it is within the protocol, there is something called as um, on database, we do this operations, which is called as CRUD operations. C stands for create. Uh, R stands for, I think, uh, C, R stands for create, and U stands for update, and D stands for delete. So this is translated onto the HTTP saying get post and the, yeah, create read, sorry, create read, update, delete. So post, and then there is something called as patch, and then there is something called as delete as. So now we have translated these database operations onto the network using HTTP protocol. So whenever you, I'll show you how it looks like. Let me put a page. Um, Here is python.org. Let me come out of this. Okay. So when you go to any website, so if you right click and look at, say, one is view page source, which is the source code of this particular page on your computer, this gets downloaded onto your computer. So this is where your uh, browser cache or cache comes into picture. This is the source code uh, of this particular page. But in the backend, there is somebody else who is serving all this data. So who is that? So on what are the calls that this browser has made to fetch that data? So that is the resource. That is why it is called as URL, um, universal resource locator, I think. Yeah. So we are trying to access a piece of data from some other computer. That some other computer is called as server. Somebody is serving this data. So if you go into inspect and look at, say, elements, sources, and there is also network. Okay. So if you look at, let me refresh. You can see that there are several calls that has been done here. So these are the, and let us look at one of them. For example, there is request URL. This is the URL. So this is the protocol header. And then there is also a method called as head, where you get the headers. And there are several uh, ways to tell what sort of data it is. So that is the structure. We don't have to get deep into that, but keep in mind that this is how the internet works. So from the basic CRUD operations, we have translated them to um, get operations. You can see that there is also some sort of post operation we are doing. So we'll look into these things. You know, so why this is needed, or why are we even talking about this? This is the basis of any computer, uh, the data interchange between two or more computers. Okay, so somebody should be, for example, if I want to get a file from different computer using FTP, I would do something like I would get into FTP command line, and then I would do something like I think get some that file from at the rate that particular file or some particular location. So it will download and say okay. Okay. But HTTP, you just need to uh, click is just a UI operation. You can in fact do it on the command line using something called as curl. There are several commands. So there is also command called as get and wget. Sorry. So yeah. So these are the command line options. Same thing that you can do it on the browser. You can do it on the command line as well. And in fact, you can do it on the using the programs as well, which we will see in a while. Okay. So why did so I showed you the source code. So if you looked at a source code, and there is certain structure for all this source code, you can see that there is some tags here, and there is certain structure to this. So why there is a certain structure to this is because browser needs to understand what is the structure of this page and what does it mean. For example, where does this particular logo fit into in this page? So what are these tabs, where does it go, and things like that. And once you click on something, how do I jump onto the next page? So all this information is inside this source code. Okay. So this sort of tags the interchange formats. So if you didn't have this interchange formats, you can almost there is no way to parse the data in structured format, right? So it's like telling a story, and then there is no structure. Like you're saying, say if you're narrating Bahubali to somebody else, you start from somewhere, and then you start from Katapa, and then you're beginning to like start where he was born and things like that. So there is no connection, there is no structure. So there needs to be structure, there needs to be introduction, there needs to be like this is where the scenes are structured and how they are related to each other. So this sort of relationship, when we narrate a story to humans, so we start of making uh, thought patterns. So, and then we try to imagine and we connect the dots. So, but computers, for them, we need to tell in such a way that there is no ambiguity, there is no confusion at all. So, in order to remove the ambiguity, you need to have some sort of structure. So that is why we have some structure. So the languages are so this um, when we define HTTP, we also define something called as HTML. So the ML stands for markup language. Marking up is nothing but this. So what I'm saying is, for example, this particular link, if you so how does computer know that this is a link? Because I'm telling that okay, uh, it comes under this particular uh, uh, list, and then this is the href. Href is nothing but some reference, so HTTP reference. Next, if you click that, take me there. So that's the way it is. So there is a markup language. So one of the markup language, there are several markup languages. One of the popular languages is HTML, another is XML. So why do we have HTML, and what is the purpose of XML, and why there are several such other things? For example, today, from past couple of decades, we have JSON, and from last decade, we have YAML files and things like that. So why is it like that? So why they are generated? So now we understood the necessity of being structured when we are communicating with the um, you know, drawing this. It's not picking up. Okay. Okay. So necessity of these markup languages. So XML was invented. So we were talking about process a little bit earlier. So now there is a human interaction with the browser, but there can also be program to program interaction, right? So P1 is there and P2 is somewhere else. So if you download a file, and then you do some operation on top of it, and there is a process waiting for that to process. So how do you do it? So do you really require a browser? Browser is only meant for human to computer interaction, right? So browser is like human to computer interaction. So what about computer to computer interaction? So where do you find this computer to computer interaction, right? So there could be say we are doing a transaction, UPI transaction, and you send money from your account to another uh, person's account. So when you do this, you are operating from your mobile, which is actually a computer, and then it goes to banks. There are several things involved in actual transaction, but let us just imagine that the only the bank is involved. So bank, when you reach the bank, there is somebody who is watching out or waiting for any message to come in, and there should be some structure in your message so that it can understand. For example, let us see. So it could be your bank account, uh, and the amount, and then a receiver's account, and Yeah, that's it. Let us start. So whether it is debit or of course it is you're trying to send money. Okay. So once you send this, you cannot send in simple text format because uh, structure is lost, and this probably gives back a transaction ID for you saying. And then if you look at the source code or the network element that is being communicated, you will find something like, probably this will be translated to something like sender's account, amount, and receiver's account, and with this data. So once you send this process is in bank. This gets read and consumed by a process, and it gets updated in the database. So if you send money through API and you check your bank account, and you can see that this there is a transaction in your account, right? So this is computer to computer interaction. So in fact, you can now you're sending money, you can also schedule your bills and things like that. So how does that happen? So that happens through this data interchange or data exchange formats. So popular formats, we saw XML, which is nothing but some markup language, and we will see more about markup language. And then there is JSON. The reason that JSON was invented is so markup languages initially targeted the human to computer interactions, and then process to process interactions. For them, you don't need a lot of tags, you just need some data. So imagine that you are sending say 100 people's or 1,000 people's transaction data on a computer. So if you have a lot of tags, it will uh, it will have more data because of just because of these tags. So how do you eliminate these tags? Is using JSON. So JSON doesn't have tags. I'll show you how JSON looks like. For example, program. Close this. So imagine we are trying to extract data from. There was a COVID statistics API before, it is disabled now, but the overall idea is this. So it's like object inside object. Say for example, overall India. So this main block is India, and there are states, say Karnataka and Kerala, and there are districts inside that. So how do you represent this data? So if you send a plain text, so there is a possibility that the format gets modified. Some other computer can, you know, change the order. On the network. It can get split into multiple files and then get into a single file, which can we can lose the order and things like that. So this data interchange formats give a way uh, to realize the structure, the object inside objects, and then a relationship between that. So it looks like this. This is how a typical JSON looks like. Say this is translated to this current. Imagine that entire file is for India and there are several states. So this is just for Karnataka. And then you can see that it is structured. Now when the computer reads, so without any confusion, it knows that, okay, this can be looked from computer point of view or the Python point of view like a dictionary. So dictionary key is Karnataka and the value is another dictionary, and district data is a key for that particular dictionary, and there is another dictionary inside that. So there is a dictionary inside that dictionary inside that, like that. So we have three levels of dictionary, which is called as nested dictionaries, and then we have data. So now there is no confusion. For example, if I want to find out where is this active cases, say 39. So is it in Karnataka, or is it in some other state, or is it in which state? So we don't come to know if you just simply send a text, right? So if you have this format, now we have the relationship between them, and use that. So that is the underlying concept of JSON. So same data, how does it look in XML is like this. So you can see that there is certain structure. So each XML has a like a protocol. So it needs to know that this is the version and this is the root data and things like that. So if you imagine, or if you want to represent the same data in terms of in terms of trees, right? For example, there is India, and then there are states, which is like Karnataka and Kerala, and under which we have districts, which is say now say Chikmagalur, and there is Ballari and things like that. Within under that we have these active cases confirmed and like that. So decision. So you can, if I want to fetch how many people or how many active cases are there in Karnataka, I will just go from here. I don't have to go to this place at all. So I can simply go here, Karnataka, and fetch all the districts and traverse through it using a loop, and again traverse through using another loop, nested loop, which a for loop, which is within for loop, and get all the active cases, and then have a variable um, somewhere here, and then sum it up, sum of all those numbers. So I will get how many number of active cases are there in Karnataka. So you can see that we have eliminated processing of all the other states, right? So now there is unnecessary, all the unnecessary processing. Imagine that we have sent just a text file, just like um, there is no order. You will have to look up and put a logic to find out where is Karnataka and how do I fetch all this data, right? So that problem is resolved. So this is why we use data interchange formats. So it, of course, there is no, in from concept point of view, there is no difference in XML and JSON. The reason that JSON was invented is because, for example, this these tags, ending tags and starting tags, you don't, these tags you don't require. So if you want to represent active, there is like two times active, right? There is starting tag and this is ending tag. So this particular symbol stands for ending, because you need to know where it ends, right? When to stop reading. But if you look at uh, JSON, so there is no starting and ending tags. There is only one nodes is equal to something, right? So this is the main difference between XML and JSON. JSON consumes less memory. Imagine that you are posting, uh, say 1 million, you are trying to pull 1 million people's data, or 1 million some transaction data, and having multiplied that by into that tags, which is number of characters, and it goes onto the network, and the downloading time it just gets doubled, probably more than double. But JSON, it doesn't take so much. And then people started thinking, okay, now we have optimized from these tags to these tags. Why don't we actually remove these braces as well? So that is where your YAML files came into picture. So YAML, I'll just show you sample YAML. You can see on the right side. So we made quite a lot of, yeah, this is an example of YAML file. So you can see that there is no flower braces that we use in uh, JSON. This this YAML file is actually better for configuration related parameters. So yeah, this is there are several research that happens in computer zone, and then people come up with new things. There have been several other formats as well, but they did not pass through the test of time. So these are the ones which people started using more, and then these are popular ones. So this is about YAML files and JSON files, XML files. All these come under one umbrella, which is data interchange format. The reason that we need data interchange format is because we need to communicate from one computer to another computer between the processes. So this is inter-process communication, but at a different scale. So if you are using the same in the same computer, probably you will have, say, one Python program to another Python program. Probably you will use some sort of function calls, and call that module, and that data gets passed. So say your mobile devices support Android. Probably there is a Java code which is running while you are making a transaction, but the code at which the transaction is processed, probably it is in Python. Probably it is some other version of Java. So how do they know that what is the format, and how these bytes are represented, right? So in order to do this representation, we have come up with different formats, common formats. So that's the key idea here. Okay. So any questions in terms of concepts, inter-process communication, and then in between the computers. So we're trying to expand the communication. Any questions?
No, Digga.
Okay, thanks.
Quick question. JSON file,
Okay,
for example, take this district, Ballari, and another district,
okay.
Chikmagalur or something. So, for example, Ballari don't have active is empty,
Yeah.
and Chikmagalur is have. Still, it considers it takes null value or something default value.
Yeah. Unless there is, so if you have zero, it will consider, because the processing computer, it doesn't know whether there is active key, or your question could be like this. For example, what if
Yeah,
there are
5 lines instead of one district has 4 lines, another district has 5
correct,
lines.
perfect. So in that case, what you generally do is you just parse it. So once you parse it, you just get a dictionary. So in your code, you need to write in such a way that whether the data that I'm trying to look, whether it is there or not. If it's there, do this. So if you're trying to sum up all the active cases, for example, Ballari, there is no active cases. This key itself isn't there. So you write in a for loop like if active is present, only then pick up that element. If it's not present, just continue. So we saw continue keyword yesterday, right? So just continue. Do not process that. Skip on to next district, like that. Okay.
What is the difference between YAML, JSON, and one more
XML.
XML?
Yeah, so there is, from the concept wise, it's all structured in a tree-like format. Concept wise, there is no difference. But for the convenience, so I was explaining, so in XML, you have these tags, right? So in order to find out active, so you need to parse this tag. So
Okay.
to represent this, there are two tags, starting
Uh,
tag and ending tag, and also
okay.
these characters, greater
So
than.
those are only tags are different.
Yes, yeah, concept wise, there is no difference at all.
Okay.
And related libraries are different while we are using it, because libraries need to know how they are formatted. So when JSON came into picture to optimize this, so if you are sending like 1 million users data, so multiply that by these little characters, and then also the ending tags, it will have like more than, say, unwanted or redundant data, say probably uh, 4 MB, sorry, for, yeah, more than for each character, I'm saying. So if it is, the even tag is bigger, and then the data will grow, right? So on the network is quite costly. Like we use it for upload and download without thinking much. But for things like transactions and uh, big data, so you cannot afford to have these tags as an overhead. So that is why JSON was invented. But there are still legacy systems which use SOAP protocols. There is something you might have heard in your offices. So in early 2000s, there was something called as SOAP protocol between the network protocols. So people used to send configuration data over SOAP messages, and then that SOAP messages would embed XML. So the still legacy systems are using that. So yeah, it's still there in the industry. And YAML, you don't have these braces at all. So you can see that you look at this, you don't have braces at all here. So YAML works on the fact that just like Python, it works on indentation. So if it is indented, so I'm getting into another object, the object inside another object. In fact, this particular JSON can be sent in one line. You don't, this is just for readability, but you can put it in one line and send it. But YAML, you cannot send it in one line because these are the indentation extra spaces or tabs, which helps computer to the process to understand the structure.
So prior to XML used to send flat file, correct?
Yeah, yes, flat files, yeah. But that is like probably in
Yes.
pre-80s. Yeah.
Okay.
Okay, so let us get into code and try to realize what we have understood. Okay, so I hope the concept was clear. So let me create a file. So I'll just take example of JSON here. And yesterday we also did file processing. So I'll take some copies of JSON from somewhere. I've copied some text from online. So let me create a file here. What can I call this? Sample.json. I'm going to paste that. So your ID will do the formatting. In fact, this format doesn't matter at all. I can keep everything in one single line. But yeah, this is just for our visualization. So you can right click and say format document, it will format it. So I have a sample.json file called as sample.json, and I'm going to write a program. How do you parse it and how the data is represented in terms of programming and in terms of data types that we have learned already. So first thing that we need to, so before writing any program, you need to take a moment to jot down the lines of what are the steps. So unless you do it, usually what happens is, for example, when we were in college, so if there is a program given to us, so we'll start writing, it was C, so we'll just start writing hash include and then do uh, write main and all these things, and then we will open this braces and start thinking from there, and then our brains sort of gets frozen. So what is next, and how do I do this processing, how do I sum it up and all these things. So that's to avoid that sort of brain freeze. It is a common thing to happen. So now we have learned, so this is whatever we have learned is knowledge. So whatever you're going to see that how to process and things, this is also part of knowledge. Until you lay your hands on the keyboard and do it, it doesn't become part of your experience, because there are a lot of errors that we are going to face, and then we need to understand why it happens, and then solve it. So once we do this, that becomes part of your experience. So there is a lot difference between knowledge and experience. So to gain that, you need to have clarity. Like before writing the program, you need to list down what needs to be done. For example, I'm trying to parse the JSON file here. So how would I think is, okay, so there is a file, so read file, and then um, read JSON file, and probably it gives, now I know that the output of it will be in certain format. So then parse data. Within this parse data, I might be having several loop through. You need to know the structure of this particular sample.json. Let me open it to write so that we have this always open and loop through each element, something like that. And if you want to get the name and ages, and then again get name and ages. So this particular JSON represents the organization. The organization name is global org, and there are several departments, and there are employees. So if you want to think in terms of whatever we try to understand from tree structure, it is quite simple. It is like this. So there is organization. So this is the main node or root of the document. And there are these sort of branches, and department comes here. And under department, there are employees. So this is what is the department and employees. And under employees, there are two types. One is name and age. So this is a structure. So employees itself is here. Employees is a list. In fact, this you can represent like list of all the employees. That is employee 1, employee 2, employee 3, and so on. So this is a structure, mental model of the of this particular file. So how do I realize in a computer? Let me, now I have written like my thought process over it, and I'm going to write. So this hash stands for comment. So this doesn't get executed in Python program. So this is just comments. So we studied open file yesterday. So what file do I need to read is this. So I'm going to copy the path and put it here. Okay, this is the path. And yesterday we saw that I get a file descriptor whenever we read the file. And let me execute fd. I'm going to check whether it is working as expected. I'm going to print all of this. Print data. So let me execute this. And you can see that it got executed. So I'm able to read the data. So once I read the data, I'm looking at this. So imagine now I need to parse this. How do I parse this? So if you had to write your own program to parse all of this, because this is just a raw data, and to convert them into dictionary, and then there are dictionaries inside this, and there are lists inside this, and so on. So it takes a lot of logic to parse a raw data, which is a stream of characters, into this into our data structure that we desire. So that is that requires a lot of effort. So in order to so these are repeating patterns, right? So so if somebody has defined the JSON, so they have also come up with people have the users, who are nothing but the programmers, other programmers, have come up with libraries where you can read the data and get data in such a way that we handle it very easily, because you don't have to think about how this gets parsed. So such a library for particular to JSON file is called as JSON. So import JSON. So import is a keyword. So JSON is a inbuilt Python library or a module. So where it is used for JSON processing. Let me do the similar thing using JSON and look at the outcome, how it looks like. Okay. So I think if we just use JSON, and there are several functions it gives us in the IDE. So I am familiar with this. So I'm going to do something like this. So yeah, what does it get? First load file, is it? Yes, takes. I hope it takes stream of characters. Okay, so let us look at this error. You will face this. This is what accounts to your experience. For example, I'm trying to send the file descriptor. File descriptor is a pointer which is pointing to this. So it is not a stream of bytes, or it is a string or byte array or anything like that. So there are functions which within JSON module called as load as, and things like that. So there is also something called as load. Let us look at how load looks like. So load takes the file descriptor. Okay, you don't have to remember this at all. So you can simply search Google and get get the code. So, but the underlying, if you get this error, what would you do, right? So again, you have to search and uh, imagine that in a big code base you are working, and this error is not doesn't come alone. So there are several errors within which this gets embedded. So you need to be you need to have that experience to find out which error points to which part of the code. So that is the thing that you gain as you program. Okay. So now we try to use load as, which doesn't support. Now we trying to use load. We are able to print. You can see that the entire JSON file is like its format is no more there, and we are getting a simple one line. So let us look into this file again. So okay, there is also if you're writing programs in on your laptop, so you cannot do this in production, but you can. There is something called as PDB. So you need to be this is a simple module. So import PDB, and then there is a module inside PDB. PDB dot set. And there is, okay, you can do this. This is there, or you can also do, there is a simple function called as breakpoint, which is actually does the same thing. So the reason I mentioned about PDB is PDB stands for Python debugger, just like GDB in C or C++, where it is GNU debugger. You can actually set breakpoints and stop the program's execution, and then look into the data that you want. Okay, analyze it. So let me run it and look at how it looks like. So you can see that this part of code got executed, and at line number 9, it stopped the execution and it is waiting for something. So we got this prompt. This is called as PDB prompt or debugging prompt. So if you want to look at the code, so in the first class, I was talking about instruction pointer. So CPU is trying to execute the next instruction, right? So that instruction is what is this particular arrow. So this is going to execute, or the current instruction that is under execution is this particular breakpoint. And there are shortcuts. You can learn about it as you program. So now I want to look at this particular data. Okay, so I'll just type data, it will print out this. Now, how do I parse this, right? So you need to know what is the type of this. So for the bare eyes, if you look at this, the flower braces starting and ending is nothing but a dictionary. So is it a dictionary? Let us look at this. Yes, of course it is a dictionary. That means the file which I have read and I have loaded to this JSON module, the outcome of this particular function, inbuilt function in this module, um, it returns me data, which is now a dictionary. So let me access, in dictionary, we know how to access an element, right? For example, I want to access, say, organization. Copy, paste. So for example, now I got an error, right? So this is what, so if you're a beginner programmer, you'll get stuck, like what is the syntax error? And it is difficult to find even this particular single quote. So yeah, so unless you try to write program, you'll not gain that. Okay. So now we have gotten into data organization. So in this diagram, we are jumping from one level to another level. So in the organization, we have this. So if I want to say print organization name, I'll just do this. You can see that organization name, because this is a dictionary. And within this dictionary, again, I'm trying to access the next key, which is the name. So a key dictionary inside a dictionary, this is how I access that. So if I want to access, say, departments, you can see that these are the departments, which is nothing but it is coming from this particular file. So there is department, one department, IT department, and I think there are two departments, HR department and IT. So now let us look at type of this particular function, type of this particular data that we have here. So if you look at this, it is a list. In fact, you can store this in a variable and do this, but this is one way of doing it. So now imagine if you want to write a program to, now this part is done. So I was telling you how to think about this. So let me clear the drawings. So this part is done. Read the. So now I'm able to parse the data as well. Now, if I want to get the names and ages, that is what my end goal is. So how do I get into each one of them? So you can write a for loop when you parse it, and then get the elements and then do it. So let me take just 1 minute to do that. I'll show you how. Or did I close it? So remember that we learned a little bit about Python debugger. You can use this. You can stop the execution and look at the variables. This is quite a handy and useful tool. So I have read the JSON file, and I know that this data is in certain format, which is data here. And let me write a for loop here. Okay. And I know that it was a dictionary. So even if you don't know, you can print and come to know that, right? So for example, I'll print this data. Don't have to remember anything at all. So this is a dictionary. So in order to parse the dictionary, I can do something like this. So if you have done assignments, so it is like you get key and you get value, and for in and that particular dictionary, which is data, I can do items. Yes, is it items? I don't know. Print a and now you can see that this got executed. So let me print a new line for every print so that we are able to line with dashes so that we know what is happening. Can we clear this? This is entire because this is one simple dictionary. Okay, so that is why we have one line here. So if you want to get into organization, so how would you do is, so for again key, say key one, v1, different variables, and I want, so data is within this particular say dictionary. I can do data, and then you can also either you can do this or you can go fetch one key by key and then look into that. So and then you can print k1 and so yeah, this is, you got this error. So it says that in this particular um, data, I do not have key and value. So now we need to sort of look into that and try to solve it. So this is how you kind of parse through the data. Let me just do and try to print what is inside that. You can see that there are like probably yeah, where is that? Once you fetch this, probably only thing that we have here is name, I think somewhere. Yeah, you got name. So name is a key. So we are just parsing. It doesn't have anything. Program. Okay. Yeah. So we have print that particular element. So in fact, you can print all this, like you can get into another for loop and then find out uh, what is the employee name uh, and particular age. So that is how you try to loop into this. So I hope you understood the concept. So now we are dealing with, we learned data types and then we learned looping, and then we learned something about data interchange formats, and then we are trying to put it together. Now we have a mental model of data, that is a tree structure, and we are trying to get into the levels of trees and getting the fetching the data and trying to do something. This is how the most of your computer to computer communication happens. So this is important when you write projects. Most important thing is to like write down what you are already you know thinking, and write it properly, and then write as much as possible so that you have clarity, no ambiguity, and then try work through the steps. So you'll get a lot of errors, and each of these errors will start making you think why it is there. And once you solve it, it becomes easier to solve next time. So you can keep solving it like it's nothing. So it doesn't take a lot of time to get to a stage where you can program and think easily. It takes about 10 programs or 10 assignments, programs in the assignments to get your there are thinking muscles in our brain, right? So get that flexed. So once it's already active, it's easy for you. So that's why it's important to write assignments and make this put your hands on your keyboard. So that's the key here. Start writing programs and then let me know if there is any problem. Yeah, that's it for today. I just wanted to show how these things work. Any questions?
Thank you.
Okay. If you have any questions,
Thanks.
reach out to me anytime. You can send a screenshot of your programs, errors, or whatever. Yeah, feel free to send.
Yeah. Thank you.
Okay.
Have a great day.
Have a great day. Yeah. Okay.
Thank you.